In Chapter 2, we will go through the various methods used to display qualitative and quantitative data. A table for qualitative data usually involves frequency distribution, relative frequency distribution, and percent frequency distribution. So we will learn how to create a frequency distribution table. When we talk about a frequency distribution, it basically depicts the number of data observations that fall into specific categories. The relative frequency distribution displays the proportion of observations of each category relative to the total number of observations. There are certain rules that we have to understand when it comes to a relative frequency distribution. Every relative frequency distribution will be between 0 and 1. When you add all your relative frequencies, they have to add up to 1. A percent frequency distribution is simply another way to present your relative frequency distribution in a percentage format. You take the relative frequency and you multiply it by 100%, and this will give you the percent frequency. Same way as the relative frequency, each percent frequency will be between 0 and 100%. And when we add all the percent frequencies, they have to add up to 100%. So, for example, let's look at this example. The final grades for 30 students, n is the sample size, so n is equal to 30, in POM to 12 are given. Construct a frequency, a relative frequency distribution, and a percent frequency distribution. So once you are given your data set, in this case you have the different grades, all in total are 30. So you break them down in categories. In this case, as we mentioned, are the different grades. And you go to your data set and you count, how many A's do I have? 8. How many B's? 8. C's? 7. D's? 3. F's? 4. So this will constitute your frequency distribution. When you find the frequency distribution at the end, you add them all and you want to make sure that the total number of the frequencies is the same as your sample size. That means you didn't miss out any of the entries. So we have 30 here, our sample size is 30, so we are good. How do I calculate the relative frequency? You take the class frequency, the frequency of each category, and you divide it by the total number. So the relative frequency for the students that got an A is 8 over 30, 0.267. Same thing for B. For C is 7 over 30, 0.233. For D's, 3 over 30, 0.1. 4 over 30 for F, 0.133. For the percent frequency, whatever you got on your relative frequency, you multiply it by 100% and you get the percentage. You basically move the point 2 positions to the right for the percentage. When you add your relative frequencies, they add up to 1. When you add your percent frequencies, they add up to 100. The most common type of graphs for qualitative data are the bar charts, the pie charts, and the Pareto charts. The bar charts are used to display data that has been organized in categories and can be arranged in a vertical or horizontal orientation. Always remember that when you create a bar chart, you should always separate the bars to emphasize the fact that you are talking about different categories. On the vertical axis, you can use frequency, relative frequency, or percent frequency. And on the horizontal axis, you have the different labels, categories, names, and so on and so forth. Pie charts are a tool for comparing proportions for categorical data. Each category occupies a segment of the pie that represents the relative frequency of the category. Pareto chart is very, very similar to the bar chart, but it's different in how it's presented. The bars are arranged in order from highest to lowest. So in this case, you have the two different examples. You have your bar chart here based on the frequency distribution table that we mentioned before. You have the different grades here, and you extend the height of the bars based on the frequency. I have used frequency here for the bar chart. And then for the proportion, a pie chart based on the proportion, the percent frequency. The whole circle is 100%. So based on that, you can arrange the different segments and use really see the proportion for each category. Now, a table for quantitative data includes, except the frequency, relative frequency, and percent frequency. It can also include the cumulative frequency distribution, cumulative relative frequency distribution. A cumulative frequency distribution basically indicates the number of observations that are less than or equal to the upper limit of each class. Cumulative relative frequency distribution is the same thing, but instead of frequency, we use relative frequency. So it indicates the proportion of observations that are less than or equal to the upper limit of each class. Now, when you have quantitative data, it's very important to understand how to create the different classes, how to separate your data into the right number of intervals, and analyze the data from there. These are the steps that will help you create the classes. First off, you decide on the number of classes. Usually it's between 5 to 20 classes based on the number of observations you have. You don't want to make too many or too few. You may also use the rule 2 raised to the power of k greater or equal to n rule, where basically k will be the number of classes that you will have to use. So it's basically by trial and error. Whenever this part becomes greater than your sample size, then k will indicate the number of intervals that you should use. We find the class width. The class width is calculated by taking the range of the data, maximum minus minimum, and dividing it by the number of classes that we want to create. Whatever the number is, whatever the decimal is, you always round up to the next convenient number, no matter what the decimal is. Now, how do we find the class limits? We always start the lower limit of the first class with the minimum data entry, and then we find the remaining lower limits by adding the class width to the lower limit of the preceding class. We find the upper limit of the first class, and then we do the same. We keep adding on the class width as we move from class to class. So let's look at an example. The ages of 25 students, that means that your sample size is equal to 25, in Math 119, are given below. Create the classes and construct a frequency, a relative frequency, and a cumulative frequency distribution. So this is the data that you are given. The data consists of 25 entries. In some cases, it will be stated create 5 classes, create 6 classes, create 10 classes. Since it's not given to us, we can use this rule, 2 raised to the k power, greater or equal to the sample size. So, by trial and error, we see that if 2 is raised to the 5th, that will give us 32. 32 is greater than 25, so this is where we stop. If it was through the 4th, it would be less than 25, so we would have to go to the 5th, for example. So, range, maximum entry is 42, minimum entry is 18, 42 minus 18 over 5, this will give me 4.8. 4.8 we round to 5. Even if this was 4.1, you would still round up, you would still round to the next convenient number. Now, we will start the first lower limit, or in other terms, the lower limit of the first class, by using the minimum entry. The minimum entry, as we mentioned before, is 18. We will add 5 to 18 to find the lower limit of the second class. So let me just show you exactly what we will be doing. So we start with the minimum entry. The minimum entry is 18. 18 plus the class width, 23. 23 plus the class width, which is 5, 28. 28 plus 5, 33. 33 plus 5, 38. We do this 5 times because we will create 5 intervals, 5 classes. Now, we do not know the upper limit of the first class. Since I have the lower limit of the first class, I subtract 1 to find the upper limit of the first class, which will make it 22. Keep in mind that classes have to be consecutive and they cannot overlap. So we know that this number will have to be 1 less than its preceding number, which is the lower limit of the second class. Once you have the lower and the upper limit class of each class, of each class, you keep adding the class width on both sides as many times as the number of classes that you need to create. So you create the classes. The next step is to find the frequency. How did I get this 15? Your first class is from 18 to 22. You will go back to your data set and you will count how many entries do I have from 18 to 22, 18 and 22 included, and you will see that you will have 15 entries. Same thing, how many entries do I have from my data set from 23 to 27, and again including both limits. Once you count the number of entries, your frequency, you add them all up. You want to make sure that this number is the same as your sample size, which it is. I want you to find the relative frequency. How do we find the relative frequency? We take each frequency, we divide it by the total. So the relative frequency for the first class will be 15 over 25.6. Second class, 5 over 25.2, and so on and so forth. Now, the cumulative frequency, you always start with the first frequency. When you create the cumulative frequency, you always start with the first frequency. So the first cumulative frequency will be 15. The second cumulative frequency will be 15 plus 5, 20. 20 plus 22, 22 for the third cumulative frequency. 22 plus 1, 23. 23 plus 2, 25. The last cumulative frequency will always be the sample size. If it's not, you've made a mistake somewhere. Go back and check your calculations again. Now, if we were looking for the cumulative relative frequency, we would follow the same process, but instead of using frequency, we would use the relative frequency numbers. So the first cumulative relative frequency would be 0.6. The second cumulative relative frequency would be 0.8. The third, 0.88, and so on and so forth. The most common types of graphs for quantitative data are the histogram, where is a special bar graph for quantitative frequency distribution. It shows the number of observations in each class as the height of each bar. The bars should be connected because your data, your intervals are consecutive, so we want to highlight this. Where one ends, the other one will, the next one will start. The vertical axis represents the frequency, relative frequency, or percent frequency. The horizontal axis will represent the classes of each group. The shape of the histogram could either be skewed to the left, that means you will have a longer tail formed to the left, as in the first shape, will be skewed to the right, that means you will have a tail forming to the right, or it will be more or less symmetric, where you will see a bell shape, normal curve as otherwise called. Now, a stem and leaf display is a graphical technique used to present quantitative data by basically splitting the data values into two parts, two stems. The first digit in the value will be your stem, and then the leaves, the remaining digit in the value. To draw a stem and leaf diagram, you put the stem digit on the left side of the graph in ascending order. Then you draw a long vertical line, and to to the right of the vertical line, you enter the numbers that are the leaves in ascending order. The stem and leaf display should always be ordered. So let's look at this example. Based on the table that we previously did, the histogram would look something like this. Again, I used the frequency. Now, for the stem and leaf display, minimum is 18, maximum is 42. So on this side, we will have the first digit from 1 to 4. And then we take each of the entries. So 18 will be 1 and 8. You have to take into account every single entry, even if it's the same number. And it's almost like an horizontal histogram, if you look at it this way. But it's a very, very easy way to kind of determine the highest concentration of your data, basically. In chapter notes, you also have the objectives and the key terms. I would highly recommend that you take a look in the objectives for the chapter, as well as the key terms that we have here. And this concludes the notes for chapter 2. Let's go ahead and take a look at the